Hello folks, I'm just doing a quick demo here of ultrasonic power transfer. Some of you may have heard of a device which has managed to garner tens of millions of dollars in venture capital money, and they're basically looking at transferring energy acoustically using ultrasonics. And I'm just going to do a quick demo here of a little setup which shows you how to use this. They're looking at it for charging phones, but they also talk about charging other devices like computers. So the object of this is just to show that you can actually do it, but then they'll probably give you more questions than you'll get answers for in this particular video. This is just a very quick demonstration to show that you can actually achieve this with quite simple setup. So what I have here is on the left hand side here I've got a signal generator which is generating a 20 volt peak to peak square wave into an ultrasonic transducer, an off the shelf one, and at 40 kilohertz this is. And then here on the other side we have acoustically coupled, i.e. through the air, another transducer acting as a receiver, clamp diode, rectification diode. So because this is AC coming off of here and we want DC to charge our phone up, we need to have a diode here. I'm using Shotkeys to reduce losses, and a little microfarad capacitor on here. Not sure if it's absolutely necessary. It's just a proof of concept, very quick one that I built up this afternoon. And I'm also measuring the current here. Now bear in mind the voltage to charge your phone is going through the USB, so that's going to be 5 volts. Now we might well find that we'll get a little bit more than that or a little bit less than that here. I'm doing no voltage regulation here. The amount of current this thing's going to be able to supply is so low that it's unlikely to cause any damage whatsoever. So without further ado, here's my setup. So here's my circuit that I have. If we look on the diagram again, here's my receiving sensor here. There's a clamp diode here. This is my rectification diode here, little 1 microfarad cap just here, and then I'm measuring the current through the USB cable on this meter here. This is my device under test, if you like, and this is just an old smartphone that I happen to have lying around. And what I should also show you is this side. So this side is just connected to my signal generator, and it's just exactly the same device as this, the receiver. So let's see what happens. Now I'm going to warn you now, you do have to get this quite close to make it do anything, but I'm going to just show you what happens when I move the transmitter close to the... See the current starting to rise here as I move closer, and you'll see, let's get it down here. If I get it just right, I can make it show that you'll see that the display came on without me touching it. If I get it just right, you can see charging, and it's charging, let's get it right again, at just under a milliamp. Now the reality is I can tell you now, this phone takes more than a milliamp just on standby. So yeah, I can pretty much maintain it saying it's charging consistently if I just hit the sweet spot. Oops. Let's see if we can maximize this a little bit. Not that steady. The wavelength is so short, so I can keep it charging supposedly for some time, and that was less than a milliamp that it was showing charge. So that's how you can acoustically charge your phone supposedly. But at 1 milliamp, I can guarantee you the drain is going to be far more than that on the battery. So it might say it's charging, but it ain't. And that's a little demo for you. Anyway, thanks very much for watching. Cheers now.